Hello, everyone. My name is Xing. I work at VMware in the cloud storage team. I'm a co-chair of CNCF Tech Storage and a co-chair of Kubernetes SIG Storage. Today, I will talk about what's new in Kubernetes CSI. Here is today's agenda. I will go over the Kubernetes CSI features that moved to GA in 1.22 releases and talk about features we're working on for the 1.23 release. The first feature I'm going to talk about is CSI Windows. CSI Windows moved to GA in 1.22 release. This is a big milestone. There are challenges for CSI drivers to work on Windows because Windows containers are not privileged yet. However, CSI drivers need to perform privileged operations such as mount and unmount. The solution is to have a privileged proxy binary named CSI proxy that runs as a native Windows process on the Windows nodes. CSI proxy will expose an API through gRPC over a named pipe for executing privileged storage-related operations on Windows hosts on behalf of Windows containers like CSI node plugins. Supported protocols include NTFS, SMB, and iSCSI. Only CSI node RPCs need to be implemented by CSI drivers to support Windows. This includes node get info, node stage onstage volume, node publish unpublished volume, node expand volume, and node get volume sets. Another thing I want to mention is that the CSI proxy approach is designed based on the assumption that Windows containers can be privileged. However, now there is also an alpha version of privileged Windows containers. CSI Windows team is working on designing a solution to transition CSI proxy for Windows to privileged containers. The goal is to make sure minimal changes are required for CSI drivers already supporting CSI proxy to move to privileged Windows containers. The next feature I'm going to talk about is pod service account token. This feature moved to GA in 1.22 release. This feature allows CSI drivers to impersonate the pods that they mount the volumes for. This improves the security posture in the mounting process without handing out unnecessary permissions to the CSI driver's service account. This feature is especially important for secret handling CSI drivers, such as the secrets store CSI driver. Since these tokens can be rotated and short-lived, this feature also provides a way for CSI drivers to receive node publish volume RPC calls periodically with the new token. Next, I'm going to talk about 3 FSGroup related features. The first one is skip volume ownership. If there are lots of files on a volume, Kubernetes will do a recursive change of all the files on volume every time the pod starts. This can slow down the pod startup time. So we introduced this skip volume ownership change option so that a user can opt out by setting a flag in pod security context, so that FSGroup will only be applied the first time the pod starts to get the right permissions. After that, pod starts should be fast. This feature is targeting GA in 1.23. The second one is CSI FSGroup policy. Sometimes FSGroup cannot be applied to volumes at all. For example, if the volume is a NFS share with a root squash option. So we have this feature for CSI driver to opt in. In CSI driver spec, there is a FSGroup policy. By default, it is rewrite once with FS type. That is the current heuristic. So to support backward compatibility. If it is set to none, it means we don't want to apply FSGroup. This is for NFS with root squash or other storage backends that do not support FSGroup at all. If it's set to file, it means Kubernetes should apply FSGroup. This should be the setting used by most CSI drivers. This feature is targeting GA in 1.23 release. The third one is delegate FSGroup to CSI driver. Some storage system can apply FSGroup more efficiently by applying it to the whole volume, for example, as a mount option. So we introduced the feature in 1.22 to delegate FSGroup to CSI driver instead of kubelet. This is moving to beta in 1.23 release. The next one I'm going to talk about is generic ephemeral volumes. This feature allows any existing storage driver that supports dynamic provisioning to be used as an ephemeral volume with the volume's lifecycle bound to the pod. As shown in this example, you can specify a volume claim template and have a PVC created as an ephemeral volume along with the pod. This PVC can be used to provide scratch storage that's different from the root disk. For example, it can be persistent memory or a separate local disk on that node. This ephemeral PVC will be deleted when the pod is deleted. There's no need to write a special driver to support the generic ephemeral volumes. All storage class parameters for volume provisioning are supported. All features supported with PVCs are supported. This includes storage capacity tracking, snapshotting, cloning, and volume resizing. This feature is beta since 1.21, and it is targeting GA in 1.23. And there is an ongoing effort to migrate in-tree cloud providers to CSI drivers. In-tree cloud providers are deprecated and targeted for removal in 1.24 release. As shown here, we have AWS EBS, Azure Disk and File, OpenStack Cinder, GCEPD, and vSphere Volume plugins targeted for removal in 1.24. There are three types of feature gates for CSI migration. The first one is called CSI Migration that controls the vendor neutral logic. The second feature gate is the CSI Migration vendor that controls vendor specific logic. The third feature gate is in-tree plugin vendor on register that controls the removal of the vendor specific login. If you're using a distro, check with the distro to see if CSI migration is already handled by distro. If you're managing your own Kubernetes cluster, take a look of the document linked here to see how to enable CSI migration. Volume expansion has been a beta feature for a while now. We have been working on fixing issues before moving it to GA. One problem is that the allow volume expansion option is in storage class, but not in the PV. We are evaluating whether this option can be copied to PV, so it no longer depends on the storage class, which can be deleted. However, doing so will break API backward compatibility. So this is still not resolved. The second issue is how to recover from resize failure if volume expansion fails. If the storage system can't expand the volume to the requested size due to the capacity constraint, currently there's no way to recover from this. There is a design proposal to address this issue. The goal is to allow users to cancel previously issued volume expansion requests, assuming they are not yet successful or have failed. Allow users to retry expansion requests with a smaller value than originally requested size, assuming previous requests are not yet successful or have failed. This is targeting alpha in 1.23 release. Now I'm going to talk about this alpha feature, boarding house monitoring. Without boarding house monitoring, Kubernetes has no knowledge of what happened to the underlying volumes on the storage system after PVC is provisioned and used by a pod. With this feature, CSI driver can communicate with storage systems and find out what happens to the volumes and communicate back to Kubernetes. So Kubernetes can report events on PVCs or pods if volume conditions become abnormal. This feature includes two parts. There is an external volume house monitoring controller that is a sidecar deployed with the CSI driver to monitor volume house from the controller side. And the second one is from the kubelet side. Kubelet also monitors volume house from the node side. In 1.22, we moved the volume house monitoring logic from an external node agent to kubelet. In 1.23, we are working on adding volume house status to metrics on the kubelet side. What we have built so far is for observation, but eventually we want to be able to do reactions based on the volume house status. The reaction part is split out as a separate design effort that we will continue to work on. Now I will talk about a new access mode, read-write once pod PV access mode. CSI spec supports several access modes. The single node writer means the volume can only be published once as a read-write on a single node at any given time. But there's a problem on how this access mode is used during node publish volume. The CSI spec defines that when node publish volume is called a second time for a volume with a single node writer access mode and with a different target path, the plugin should return failed precondition. For CSI plugins that strictly adhere to the spec, this guarantees that a volume can only be mounted to a single target path, which means single node writer restricts access to a single pod on a single node. This behavior conflicts with original definition. Due to this conflict, we do not have an access mode that represents multiple writers on a single node. To solve this problem, in CSI spec 1.5, we introduced two new access modes as shown in the table. Single node single writer is corresponding to the new access mode, read-write once pod, and single node multi-writer is corresponding to the existing access mode, read-write once. If a driver does not support this new access modes, then the behavior does not change. There are a few other features that are still in design or prototyping phase. I included some links here for your reference. That's all I have for this session. Thank you all for attending. Goodbye.